Hello all, welcome to today's video. Today we have an exciting topic to discuss in the world of .NET programming. We'll be diving into the concept of lock objects and how they can be used to synchronize access to shared resources. So grab your coding gear and let's get started. So before we dive into the implementation details, let's first understand what a lock object is and why we need it. In multi-thread programming, when multiple threads try to access a shared resource simultaneously, we might encounter conflicts or race conditions. To prevent this, we use lock objects to ensure that only one thread can access the resource at a time, while other threads wait for their turn. So, alright, let's dive into our code and see how lock objects work in practice. I have a simple .NET console application set up here and will be using C Sharp for demonstration. So here I have a class called shared resource that represents our shared resource, which is in this case counter, and it contains a counter variable that we want to protect from concurrent access. Therefore, this counter variable in particular is being accessed by multiple threads. Therefore, we want to protect this particular shared resource. So how we can do in the code that let's see that. So for that, in this example, we are using the lock syntax and using this object as a lock object. It means that the lock will be associated with the instance of shared resource object. Now let's create a few threads and see how they interact with our shared resource. So I have a main program here. We have a shared resource object instantiated. I have created two threads, and these two threads actually run the same API called increment counter. And I'm starting the through two threads, and after starting, I'm trying to join it and printing the final value in the console. So let's see how it is it turns out. So let's try to run the code and see what happens. I'm building it, build it succeeded. Just try to run it. Right? Yeah. So we got the output as 2. Since we had two threads accessing the shared resource, and this particular subroutine gets executed two times by the two threads. So these two threads share the common resource called counter, as it is a member variable of the shared resource object. So finally, the counter value turns out to be 2. So here we create. So as you can see, the final counter value is 2, which is what we expected. Without the lock object, we could have run into a race condition and ended up with an incorrect or unpredictable counter value. So while using this as a lock object works in many scenarios, it's not always the best choice. In some cases, you may need to use a different object as the lock. For example, you might want to create a dedicated lock object, as you can see in this example, to provide more fine-grained control over synchronization. For example, if there are multiple shared resources and in this particular object, then if you want to provide a fine-grained control access to those shared resources, you have to go with a dedicated lock object. You have to create a dedicated lock object to protect those shared resources. For one disadvantage of using this object as a shared resource is, since this particular object is publicly accessible, therefore anybody can access the object of shared resource. What I meant is, I have a class. Let's define a class here. Let's call it my class, and I have a private member here. Private, I have a shared resource member here, m underscore shared resource. Let's call it m underscore shared resource. Therefore, I have some APIs here. Some APIs called public void show or calculate. I have some API here, and I am using the lock syntax here. Instead of using the lock object, I am trying to use the lock object as shared resource object as a lock object. So what happens here is if these two classes are part of our application and these two classes have some member have some resources which are shared and they want to protect those shared resources using the lock object. Therefore, in this particular class, we are using this as a lock object, which is nothing but the instance of shared resource. And in this particular class, we are using the same instance of shared resource as a lock object. Therefore, what happens is we are trying to protect unrelated resources using the same lock object. Therefore, this can turn out to be deadly because once you acquire a lock on this particular shared resource, when another thread try to access this particular resource, it will not be able to access since this is already locked by another thread. For this situation can arise in your application during the runtime. So this is why we don't encourage using the public members as a lock object. For anywhere in your code, it is best practice to use the private member as a shared resource object. Therefore, if you see here, the lock object here is a private object. So and there you have it. We have explored the concept of lock objects in .NET and demonstrated their usage in multi-thread scenario. Remember, lock objects are essential when dealing with shared resources to ensure safety and prevent race conditions. So I hope you found this vlog informative and helpful. If you have any questions or want to see more content like this, please let us know in the comment section below. And don't forget to like and subscribe our channel for more exciting programming content. I also have a corresponding blog post related to the same topic, which is quite in detail. I will link in the description box below. Just check out the description box for those links. Thank you. And until next time, happy coding.